Warm up for lesson 4-3. Pause to do the problem. Here's the answer. Pause to do the problem. And here's the answer. Lesson 4-3, solving quadratic equations by factoring. Write a quadratic equation in intercept form and solve quadratic equations by factoring. Let's take a look at the standard form. It looks something like this. And this standard form is helping us figure out where the x-intercepts are. And the reason I know that is because y is 0 right now. This standard form can be written in its factored form. And the factored form reveals the intercepts. So you can see that one of our intercepts is 2. And the other intercept is 6 right here. So 2 and 6 are revealed right here. Now notice that the form looks something like this. Ax minus p, x minus q, where p represents one of these two numbers and q represents the other number. A review of FOIL method is just the distributive property, and the words FOIL help us to remember to multiply 4 times to get the whole two binomials multiplied. Let's go ahead and practice the skill of being able to write a quadratic equation in standard form. All right, right now we know that the parabola crosses at -2 and 5. It may be going up or it may be going down. Right now, all we know is that it's -2 and 5. Okay, so here is the form x minus p and q. So all we're going to do is, instead of p, we're going to write one of our numbers, so that'll be -2. Instead of q, we're going to write one of our numbers, which is 5. 2 negatives in a row make a positive, and then we don't have to simplify that. Now this says standard form, which means we have to continue to multiply. So I'm going to use FOIL to help me multiply out. So this will be x squared minus 5x plus 2x minus 10 equals 0. And then I'm going to simplify by combining like terms. And this is the answer. This is what we call standard form. All right, let's do it again. And we have a quadratic equation. It could be going down or it could be going up. What we're going to do is we're going to use this standard form, or I should say template, to do the intercepts. And we're going to substitute for p, and one of the numbers is -1, and substitute for q, which is -5. Clean up by 2 negatives in a row, make a positive, so that's +1, +5. All right, and now I'm going to use FOIL to help me multiply out so I can get into standard form. So it's x squared plus x plus 5x plus 5 equals 0. And just clean up a little bit with like terms. And this is the answer. This is the quadratic in standard form. Let's go ahead and take a look at something a little bit more complex. This time the roots are a fraction. One is a fraction and one is an integer. So again, we're just going to substitute our p and our q into the format. And when we do that, we're going to clean up a little bit, and we're going to distribute. We're going to multiply x times x, and then x times -6, and then 1/3 times x, and then 1/3 times -2 to get this. Now, what the author did is he actually added these two together, so he got a common denominator and he put it together here. And in order to get it in standard form, since we have a fraction, we're going to multiply this whole side by 3 and multiply this whole side by 3, and then we get a nicer looking standard form that has no fractions in it. One more example. Here's one with 3/4 and -5. And again, we go ahead and put it into the format, clean it up a little bit, multiply through everything, and I decided not to try to get a common denominator here. I just decided I'm going to multiply by 4 to get rid of fractions. And when I do that, I get this expression, and I just clean it up by adding these two together, and here's my standard form. Your turn, pause, and here's the answer. And again, at this point, to clean up the fractions, you're going to multiply both sides by 4. All right, we're going to solve equations by factoring. And the reason why we like to solve by factoring is if you can get two numbers multiplied together to equal 0, then we can set each of these factors equal to 0, and then we get our solutions. So that's the option we're trying to do. Okay, let's take a look at this problem. This has a greatest common factor, and that happens to be 8x. So I pull out an 8x from both of these terms, and I get this. Here are my two terms that are being multiplied. So I'm going to use the zero product property, set each one equal to 0, and do my algebra. And then I get two answers. This will be one of my answers. This will be the other answer. These two answers, when I put them back into here, will equal 0. Okay, we're going to solve each equation. I can see my greatest common factor is 5x, so I'm going to take a 5x out, and I'm going to have 4x, and then if I take a 5x out, that's going to be plus 3 is equal to 0. I'm going to set each one equal to 0, and I'm going to divide both sides by 5. That'll give me a 0. This will give me 4x equal to negative 3, and then I divide both sides by 4, and here are my two answers. In this particular problem, 4y is the greatest common factor, so I take a 4 and a y out, I'm left with y, take a 4 and a y out of here, and that's plus 4. I have two things that are being multiplied, so I'm going to use a zero product property, set each one equal to 0, and I'll get a 0, y equal to 0, and y equal to negative 4, and these will be my two answers. In this particular problem, 6a to the 4th is my greatest common factor. I'm going to take a 6 out and a to the 4th, and then I'll have just 1a. I'll take a 6 out here, and then I'll have a 3 left, and a to the 4th, and that's all we have there. So then I set this equal to 0, and I know that the answer has to be 0. The only way this thing is going to be 0 is if a is 0. Now I'm going to set this equal to 0, and I can see a is equal to negative 3. All right, pause and see what you can do, and here's the answer. All right, let's take a look at perfect squares and difference of squares. In this particular equation, I have a perfect square right here. X squared is a perfect square, and 64 is a perfect square because it's 8 to the 2nd power. Now, when this number 8 and this number x get doubled, which they are right here, then that's an indication this is a perfect square trinomial. What ends up happening is as you factor, you're going to find that each one of the factors ends up being the same. So I can do it right here. I'm going to split up the x. I'm going to split up the 64, 8, and 8. Since everything is positive, I'm going to put a plus here, equals 0. And I can see that my outer and my inner do make the 16x, so I know this is correct. And so I can set each one of these equal to 0, and I'm going to get the same answer, so I really just have to do one of them, and that's how we're getting this answer. And this is called a perfect square trinomial. Now this quadratic, I'm going to take the 64 to the other side, so I have this equal 0, otherwise I can't use the zero product property. And when this happens, I see a difference of two squares. When you have a difference of two squares, something really nice happens. You split up the x, you split up the 64, you put a plus in one and a minus in the other. And the reason why is because we want to have the outer and the inner become 0. That's why no middle term is showing up. Now when that happens, you set each one equal to 0, and you get two answers right here. Okay, so let's go ahead and practice again. I can tell this is a perfect square trinomial because this is a perfect square and this is a perfect square. So I'm going, and I know that this is the double of the terms there. So I'm going to split this up, 2x, and I'm going to split up 9, 3, and 3. And they both have to be the same. They're both minuses because a negative times a negative is a positive. I'm going to check my answer. The outer is negative 6x, the inner is negative 6x, and that's exactly what I have here. So I'm just going to set one of them equal to 0, and when I get that, here's my answer, 3/2. Over here, this is a greatest common factor option, So I'm going to take out a 9 and an x, and I'm going to be left with 9x, and then when I take a 9 and x out, I'm going to be left with 1. I'm going to set each one equal to 0, and x is going to be 0, 9x is equal to 1, x is equal to 1/9. This is a greatest common factor opportunity. 3 and a, I'm going to pull out. When I take a 3 out, I have a 2a left, and here it's -1. And I set each equal to 0. That's the zero product property. A is equal to 0, or a is equal to 1/2. Okay, let's go ahead and some just regular ordinary factoring. Here we go. And split up my x, and I'm going to think of numbers that make 30. And numbers that make 30 are 30 times 1, and 15 times 2, and let's see, 10 times 3. That looks like a good option, 10 times 3. Nope, I'm trying to make 11, so I'm going to keep going. Let's see, there's also 5 times 6. 5 times 6, that makes 11 right there. So 5 and 6 are really good options. Now remember, I've got to get a positive for my last, and my outer and inner must add up to negative numbers, so I'm going to make that negative. And my outer is -6x, my inner is -5x, so I'm good. Now I'm going to set each equal to 0, and the two answers are 5 and 6. Over here, I'm going to split up my x, and I'm going to think about what makes 21. What makes 21 is 21 times 1, or 7 times 3. 7 and 3, their difference is 4, so I want that. One of these have to be negative, and one of them has to be positive. Since I want more negatives, I'm going to put the negative with the 7 and the plus with the 3. And you can see my outer and my inner do check out, so I can set each equal to 0. That's the zero product property. And here are our two answers. Okay, let's talk about a little bit more in depth. Suppose you have a number in front of the x. The factoring is a little harder. Some of you can do trial and error, but here the AC method really works well. This is the A term, and this is the C term, and this is the B term. If you multiply A and C, that makes -30. So I'll put -30, and you put the B term underneath, which is the 13. So you're taking a look at -30 and trying to find two numbers that multiply to -30 but add up to 13. And I think two good numbers are 15 and 2. 15 and 2 will multiply to be 30, but I want -30, and I want it in such a way that when I add these up, I make a positive 13. So I'm going to want the negative here. These two will multiply to be this, and they'll add up to be this. Now, when that happens, I'm going to replace, right here, I'm going to replace the 13x. So 6x squared plus 15x minus 2x minus 5 is equal to 0. Okay, now I'm going to do grouping right here, and the grouping was GCF, 3x, and then this is going to be 2x plus 5. And then right over here, I'm going to factor out -1, and then this is 2x plus 5. The idea is to try to get the same binomial here, and I have. So now I can factor it out, 2x plus 5, and what's left is 3x minus 1 equals 0. Now I set each one of these equal to 0, and I'm going to get 2x is equal to 5, x is equal to, oh, I should say -5, -5 halves. 3x is equal to 1, x is equal to 1/3. Let me show that again. AC, multiply the A and the C, and that's going to be -18. My B term is -7. And I'm looking for two numbers that multiply to -18 but add up to 7. Some good numbers are 9 and 2. 9 and 2. Now remember, I want to multiply to -18. That means one of these has to be negative, and I want more negatives, so I'm going to put the negative right here. All right, now I'm going to replace that middle term. 3x squared minus 9x plus 2x minus 6 is equal to 0. Do greatest common factor, 3x, x minus 3. Greatest common factor is 2, x minus 3. And you can see the binomial coming up. It's both the same here. So we can factor it out, x minus 3, and then 3x plus 2 equals 0. Now that we have factored, we're going to set them both equal to 0. And so x is equal to 3, 3x is equal to negative 2, x is equal to negative 2/3. Okay, your turn, pause. And here's the answer. Let's take a look at an application. We have a quadratic here, and it's asking us how long does it take for the ball to hit the ground. So the ball's up in the air, going up like a parabola, and it hits the ground here at 0. So the ground is when h is equal to 0. So we want to set 0 equal to 80t minus 16t squared. Okay, and I'm going to look for the greatest common factor, which looks to me like it's going to be 16t. So if I take 16t out, then I'm going to have a 5 minus t. So then I'm going to set each equal to 0. So t is equal to 0, and 5 equals, and if I add t to both sides, 5 is equal to t. So the answer to the question is at 5 seconds, it will have a height of 0, and a height of 0 is when it's hitting the ground. Last problem, pause, and here's the answer.